and down the west coast, with cool waters being found in the western Pacific. However, this time it's different, and here is why. Look at that warm anomaly that is extending off the coast of northern Japan and the Kuril Islands, going all the way towards almost to the international date line. Look how this warm tongue extends to the eastern Pacific. But if you look in the sea of Okhotsk, Moре Okhotska, as I say in Russian, look how cold the waters are. This is Siberian air just infiltrating, the Sea of Okhotsk, the Sea of Okhotsk. It means that there's a lot of cold air building up over Siberia, colder air than normal, which means that how much snow falls in Siberia this fall will likely be above normal. So how much snow falls in Siberia this autumn, especially October, will likely be above normal, especially because of all this warm water in the Arctic. This will enhance precipitation. Not a great amount, but it will enhance precip in Siberia, because there will be some cold moisture that will be heading into Siberia, clashing with the warm air masses in the steppe, and this will create for some pretty impressive snows, especially in eastern Siberia. This could mean that Siberian snow extent, especially in the eastern part of Siberia, will likely be above normal when we are heading out of October. If this happens, it depends on how much above normal we are. If we're well above normal, this could mean that air pressures in Siberia will start to rise towards the winter, and this would force a ridge to build over the Bering Sea and potentially disrupt the polar vortex and initiate something known as a SSW, or a sudden stratospheric warming event. You don't always need Siberian snow, high amounts of Siberian snow, to trigger an SSW. It could also be because of the PDO. The PDO itself, a positive PDO itself, can trigger a sudden stratospheric warming event. However, this time it's different. It is different than 2014, 2015. It is different than 2009, 2010. Because while we were having a weak El Niño both those times, 2009, 2010, Northern Pacific was in its cold PDO. You had a cold PDO with warm waters off of Japan and cooler than normal waters off of Alaska. And this was very prevalent during the winter of 2011, 2012, which is why Alaska had near record sea ice coverage. However, the last warm PDO wasn't as warm as it is now. Every oscillation is becoming warmer than the last. The last cold PDO isn't as cold as this one, for instance. The last warm PDO in the Pacific was not as warm as this one. Because keep in mind, look how warm the entire Northern Pacific Basin is. This will also mean that there's going to be a likely chance for very significant atmospheric river events. Even though there's some cooler than normal waters right here between the equator and 20 degrees north in the tropics, just around Alaska, you are having a pretty strong El Niño. Not very strong, but a moderate El Niño. But also the waters in northern Alaska off of northern Pacific are very warm. So yes, it's likely that California will have more atmospheric rivers. And depending on how the PDO sets up, it could also mean a lot of cold weather for the West Coast. Or not much colder than normal because we're in an El Niño, so you'll have some ridging on the West Coast, but there'll be significant troughing on the East Coast. So this could mean very wild weather. We may have something like this going on this winter, where you will have ridging here and troughiness on the East Coast, so something like that. or maybe more amplified. Like, it'll be something like that, for an instance. I don't think it's going to be that amplified, but, you know, it's going to be more smoother, of course. It'll be something like this. You know, it may be something like that. You know, I'm just trying to give an example of what could happen. It's one of many possibilities. And see what I did there. And that's the track that can lead to major blockbuster snowstorms this winter. The track I just drew is a major blockbuster. So you would have storms coming into British Columbia and the coastal part of, you know, like of the far southeastern tip of Alaska, going into British Columbia, into part of Nunavut, and then they'll come down as Alberta Clippers, come down, possibly combine with a subtropical jet and lead to some major cyclogenesis, major bombogenesis right here along the coast. So this could be really significant this winter. Really significant bombogenesis right here. You may have a, you know, like the winter of 2002, 2003, you had clipper systems combining with coastal systems that, like, when the jet streams would merge like that, when a subtropical jet and the Arctic jet would merge, you know, from a clipper combining with a storm system that would come in the West Coast to major storms on the coast. Keep in mind, the winter of 2002, 2003, the NAO wasn't that active. Yes, there was some episodes of negative NAOs, but keep in mind, Labrador wasn't that warm. So again, very, very major potentials, very significant potential for major storms along the East Coast, January, February, and into parts of March. Another thing that I'm going to get talking to is the Atlantic hurricane season, which is still very active. We likely will not break any records this year because of the El Niño, you know, somewhat suppressing activity because of sinking air. Because, you know, you have rising air here. So what is going on here is with El Niño, you have rising air. So air that is rising here and air that is sinking over here. That's what normally happens. But because it's so warm in the Atlantic, record warm in fact, you're not getting that much sinking. You are, but it's being negated by all this heat. So there's a lot of latent heat in the intertropical convergence zone. So any storms that do come off of Africa will still encounter some wind shear, as Lee did, which is why Lee went from Cat 5 down to Cat 3, even Cat 2, because he was getting southwest shear and some dry air intrusion, again, because sinking air. So it kind of interfered with the system. If we did not have an El Nino this year, Lee would have just continued to explode and would have continued to be a Cat 5 up to when it reached the cooler waters near Bermuda. So this would have been an even worse system had it not been for El Nino. El Nino, the shear from El Nino weakened the system. So we have El Nino to thank for that. But El Nino could also be the reason why we have such an active storm season. Strong El Nino would lead to warm and mild winters in the Northeast, because it would create almost ridging, like it would push the jet stream so far north. But a weak to moderate El Nino, kind of like we're seeing right now, it's more stronger in the eastern part, but more weak to moderate in the central and western. These type of El Ninos typically bring very stormy weather to the Northeast. And especially if it combined with blocking or with very warm AMO, an El Nino combined with a warm AMO can lead to some major storms. So again, the potential is there for a very cold and snowy winter for the mid-Atlantic and Northeast. I looked at the Farmer's Almanac prediction and I kind of was laughing. It's they're just saying, oh, Florida is going to be warm and dry. No. Florida is going to be very wet. South Florida, too. They might be right because, Cheshire might be a little further north. But, again, if any storm system like the 93 superstorm happened, Florida might just really quickly get wetter than normal winter. So I'm thinking, seeing how warm the Gulf is, it's a no-brainer that Florida is going to be wet. As for the deep south, there might be some cold air blasts. There might be some ice storms potentially. Northern Louisiana, central Mississippi, central Alabama, central Georgia. Atlanta might actually see a couple of snowstorms. It's very much possible. Northern Florida might see one winter event, most likely freezing rain. I'm not thinking too much snow, though. This El Niño is a little too strong for that. But yes, this winter will likely be very, very intense for the East Coast, especially if you're north of Florida. If you're in northern New England, it's going to be warmer than normal. And that's typical not only during an El Niño, but during a negative North Atlantic Oscillation year during an El Niño. So we had this happen in 2009, 2010. You had a lot of blocking. You had a weak El Niño. So yes. And that warmth comes from the ocean temperatures, from the warm ocean. So yes, Maine, New Hampshire, Maine, New Hampshire, Vermont. But basically, the further east you go, the warmer it will be. So, as for central New York, the further south you go, the cooler it will be. And also, the further west you go, it will also be cooler. So, as for Syracuse, I'm forecasting between 80 and 100 inches of snow. And Oswego, between 70 and 90 inches. Again, Oswego's right off of Lake Ontario, which is running really warm right now. And because of that, there might be some lower snow totals than normal. And if you are in the Tuckahoe Plateau, Watertown, Pulaski, New York, if you're in the lake effect snow areas, especially west and on the leeward side, the leeward side of Lake Ontario, or as I say, the windward side, so where the winds come off the lake, you're going to get a lot of snow. Significant, likely more than last winter. There was still a lot of thunder snow in Watertown, and they did get a lot of snow, but this winter may be even worse for Watertown, Pulaski, and the Tuckahoe Plateau may get even more snow than last winter. Oswego, last winter when I was there, had its least snowiest winter on record, only coming in at 23 inches when the normal is 110. This had a lot to do with the La Niña. It was more so that there was not many storms. There was a lot of just almost all the snow that Oswego got was lake effect. There was one from a storm system, but I would say 8 to 10 inches came from storms, 8 to 12. The rest came from lake effect. Oswego got like half from lake effect, half from storms. Usually Oswego gets mainly from lake effect. This winter, I think it will be another half and half year, but this time you'll have more lake effect and more snowstorms. Though there's potential that some of your heavy snow totals might be to your south, like Binghamton, because of those storms that would go up the East Coast, or even potentially curve back westward a little bit and kind of like hug the coast. So that means central New York might get a big thumping of snow. Poughkeepsie, Albany, potentially, but I really think the jackpot for this winter will be just west of New York City. I think Albany will probably see 40 to 70 inches. Again, reason I'm not giving so much snow for Albany is because some of the blocking might keep some of the snow further south. So instead of just going up the coast, it may be forced a little bit further to the south, or may even back inland and, bring snow to the interior northeast. There could be a couple of inland, what I would call, Appalachian runners that low pressures that go up the spine of the Appalachian. Those storms, if those storms happen, those storms could potentially give significant snow to the interior Northeast, even Syracuse. Because, when storms run up the spine of the Appalachians or cross it, you'll get a secondary low that'll form along the coast, plus cold air damming. That'll enhance cyclogenesis closer to the coast and along the spine of the Appalachians, especially western North Carolina. So there also could be a storm track that'll go up the East Coast and then kind of just go up and then east or stall out. We may get a couple of loops, may get potential storm that will stall out or just slowly move. If any of you remember historically, the blizzard of 2000, President's Day snowstorm of 2003, New York City got a lot of snow. JFK got almost 30 inches. It was it wasn't officially a blizzard. The winds weren't strong enough, but I would consider it a blizzard. It was very windy. There was a lot of snow coming down. The winds were, I would say, we definitely had near blizzard conditions. There was definitely a lot of snow drifts. In my opinion, it was a blizzard. Not the worst one that I saw. The worst one that I saw was the post-Christmas Day snowstorm of 2010. December 27th, 2010 was the worst snowstorm I have ever seen. The amount of snow, not the worst, but the wind was the worst I have ever seen. Winds were 50, 60 miles per hour. The winds were horrible. And the snow felt like it was stinging. There was even some sleet mixing in too. Because I heard, when I was driving when I was in the car coming home from seeing a movie with my dad, I heard what sounded like sleet hitting the window. That might have actually been some sleet because there might have been some warm air mixing aloft. But again, temperatures were actually in the low 20s, in the upper teens. That might have just been the snowflakes being flung so hard against the window from the wind that it sounded like sleet. But there might have been some warm air mixing aloft because of how wound up the storm was. But, but when I was outside, it didn't look like sleet. The snow was very dry, very fluffy. I even saw constant strobing, what looked like lightning, constantly flashing just almost every second. I thought it was from a nearby emergency vehicle flashing its light, but no, it was actually lightning. There was so much lightning, and it wasn't that bright, though. There was no thunder. It seemed like a constant That must have been a very convective snow band, because at that time, that's when the winds were the strongest. They were howling. They were ferocious. They were easily 40, 50 miles per hour with 60 gusts. The trees that had no leaves on them were like swaying back and forth like crazy. And it was just a crazy storm. And this happened on December 27, 2010. So let's look at 2010. We had an La Niña at the time, but keep in mind that water temperatures at the time in the Pacific were very cold. So we were having a La Niña, not an El Niño. We were having a La Niña at the time. As you can see, we had a La Niña. We had basically classic cold PDO conditions, beside that little sliver of warm, but it's barely there. But this is why we likely had all that snow blocking. And how did we get so much snow? Well, you know how we had a negative, we had a cold PDO, positive, a negative NAO? Well, because of this, you had basically troughiness on the west coast, but instead of ridging on the east, you had basically the whole United States was cold. So whatever storms crossed the country, they just crossed and then went up the coast. And again, the winter of 2009, 2010. So let's go to 2009. And let's go to August. Let's go to September. Let's go to September 10. Let's go to 14th. Again, El Niño conditions, not as strong as they are now, but look right here. Look how warm they were, just off the coast of Colombia and parts of Ecuador. You had temperatures of 3 to 4 degrees Celsius, and you had a significant flooding because of that. And also, that was upwelling right here from a hurricane. That's tropical system upwelling. Nothing too significant for 2009, 2010, for 2009, but look at that. Look how it was getting warm up there. It was cold in Labrador in September 2019, September 2009. But by the end of September, started to get a little warm. You started to get a couple warm patches. Nothing too significant, but you also had an El Nino, right? So by November, look what started happening. You started getting a little warm anomaly developing. Nothing too significant, still largely cold, but look, started getting a little warm anomaly right in the middle of Labrador. Now let's go to December, going to the end of December. Boom, look. It was warm. The winter of 2011, 2012 was warm as well, but you had a very, very, very cold PDO. Like, it was classic cold. Not supportive of major snowstorms. So let's go to December, end of December. Again, very cold. The warm anomaly is weaker. You could barely notice it. But again, 2010, 2011, let's go to December, or let's go to August or September, where we are right now. Now, at the same time, again, very warm waters off of Labrador. And also some warm waters off of Alaska, but classic warm PDO, cold PDO conditions were starting to develop. Plus, you had a very strong La Niña with a little bit of warmth. I mean, look at that. Right off Colombia. You see that right there? The little warm anomaly right there. And so 1, 2, a little bit of warm. So you had dominant La Niña with a bit of El Niños. Kind of a little weird. I mean, that kind of it still averaged out towards La Niña conditions, though. And by the time we got to November, again, warm anomaly. But by the time we got to December, keep in mind that the warm anomaly is coming off from the El Nino of 2009, 2010. So now look what happens. Completely gone, basically. Your La Niña, El Nino, completely gone. All La Niña conditions. Classic cold PDO during La Niña, but significant blocking. Look at that. That's why we had so much snow. 95, 96 was very similar. So let's see how far we can go back. I think the furthest we can go back is like 97, 98. Yeah. Let's go to 96. Let's go to August. That's the furthest we can go back. It's August 3rd. Yeah, and look at that. Warm anomaly right there. So yes. Again, also some warm PDO during a La Niña. Look at that. So yeah. I mean, this is August 1996. But you could imagine what January 96 looked like. Probably very warm here. You know, it's probably warm or some cool. But yeah, you had blocking. That's the thing. Very important thing. You had blocking because of this. This led to blocking. 2011, 2012, you didn't really have any blocking. So let's go to 2012. Let's go to January of 2012. Again, very cold. Look at that. The whole Labrador Sea is cold. Beside that little sliver of warm. But again, 2012, 2013, you know, we had Hurricane Sandy, right? So let's go to August. And look what started developing. Very warm waters in Labrador. So again, blocking, right? Let's go to October. Just before Sandy formed. Just, again, warm temperatures, right? Let's go to end of November. See, again, warm. And that's why we had, you know, Winter Storm Jonas. You know, we had Winter Storm, I think it was a big winter storm. I think it was, yeah, Winter Storm Jonas or Janus. Winter. TWC. Don't allow. Yeah, Winter Storm Nemo. That's the one. Winter Storm Nemo. Yeah. And look how New York City also got buried by that storm. All right. 5 billion. Oh, billion. So Winter Storm Nemo occurred in February 2013. The NAO wasn't too negative. It wasn't really a negative NAO, but let's go to December. Again, cold waters off of Labrador from cold air coming off, but look, still pretty warm. Still not too warm, so blocking wasn't that prevalent. Again, look, a little bit of sliver of warm. By the end of January, look at that. 2013, 2014 was actually one of the coldest and snowiest winters in New York City. It was just awful. And at that time, guess what was happening in New York City? This was like just before all the craziness happened with all those like bone dry snowstorms. You started developing warm waters right here. So right there, started developing warm waters. Warm PDO conditions were starting to develop. And let's go to January. Let's go to the middle of January of 2014. This is middle of January of 2014. Again, not very warm here. You just see that little sliver. But look what was starting to happen. The warm water was migrating west. East. It was starting to migrate east. Look, so you started developing warm PDO conditions and also a little bit of warm. 2014, 2015, you had classic warm PDO conditions develop. Just classic. Just the absolute, right there. Cold PDO, warm PDO, classic warm PDO. But the blocking wasn't too strong. But you had a very classic warm PDO during neutral, maybe slightly weak El Niño conditions. So, again, Boston had record snow that winter. Record snows. Boston, snowiest winter on record. Most of this happened in the end of January, beginning of February. So let's go to middle of January of 2015. Oops. Let's go to, again, 2015. We're going to January of 2015. So like middle of January, right here. Again, classic warm PDO. And right now, let's look at right now. What's going on right now? We're having a pretty substantial El Niño, not a very strong one, but we are having El Niño conditions. But look how warm it is right here. And this looks a little suspicious. You know, this looks like, are we going to have a warm or a cold PDO? This looks like a little bit of both. Anyway, I got to go right now. Thank you so much for watching, and have a great day.